Hi, and welcome back to Null Zero Labs. And in today's video, we're going to be configuring a Cisco Nexus vPC. Why? Because we always want to get rid of that spanning tree. And this allows us to do that with multi-chassis Ethernet. So let's jump into the lab. Okay, so here we are in the lab, and we have our 2 core switches and our 4 top of rack switches that we want to connect redundantly to our core. Now, in an ideal world, this would have been a chassis switch with multiple power supplies, dual supervisor engines, and different line cards so that you could have the redundancy to a single chassis. But this is 2 chassis, and we all know that if you want to use port channels have to terminate on the same switch. So to achieve that with 2 separate chassis, we use multi-chassis Ethernet or virtual port channels. So we're going to configure some virtual port channels between the setup on this core here, and we will then connect each of the top of rack switches to the cores and generate our port channels so that we can have our redundant connection from our top of rack switches with the increased bandwidth that also offers, and the ability to not have to have spanning tree in our way for slow recovery times if a link fails. So let's jump onto the 2 core switches that I've got here, and we'll start configuring those. So we'll log in. This is just a blank configuration. There's nothing configured at the moment. Now, to configure a VPC, we need a couple of things configured between the cores, and that's going to be a peer link and a keepalive. So the peer link is like a backup channel where the traffic can flow between the 2 switches. To the VLANs that are down here, they have a path to get across if one of these links was to fail. So that's how they can take a different path and get across. The keepalive is how it knows that the other peer is up, so that it can fail over from the primary to the secondary. Normally you'd put this in a secondary VRF, but as we're kind of limited for ports, I'm going to use the management interface as the keepalive interface. Obviously, if you've got a switch with dual supervisors, you'll probably want to add a secondary switch and connect the management interfaces to the switch, and then do it that way. But normally you would try and work out what's your best option. So, you don't want to waste an actual switch port you could use for data traffic when you've got the management interface. And so we will jump on. We're going to need a couple of features. We're going to need LACP, of course. And we're going to need VPC. VPC. There we go. So that's our 2 features. Now let's start with the management interface. And we'll give this a description of keepalive. And we'll give it an IP address. Okay. So this is core switch 1, and we've given a keepalive address on the management interface that we will use. We're then going to create our VPC. So we're going to go VPC domain. We'll give this a number of 100. Each one that you set up, you'll want them to be different numbers. So we will use VPC 100 for this domain. We then want to enable peer switch. Okay. We will then set a role for this switch, lowest the role priority. The lowest obviously wins out of the pair. So we'll set this one as 50 because we'll want this one to boot up as the primary, this one to boot up as the secondary. Obviously, if they fail over, one will become the operational primary, the other will become the operational secondary, and they'll fail backwards and forwards as they need to. So we set that. We are then going to set the system priority. This is for the LACP, because we're then going to set our peer keep alive destination, and that's going to be our secondary one. So that will be 10.1.1.2, and our source will be 10.1.1. Destination will be 10.1.1.2. Now source will be 10.1.1.1, which is us. Now, if we were doing it with a VRF, we would then add VRF and then the name of our VRF that we had created to keep this traffic separate. But because the VRF is default to management, even if I add this, you'll see that it doesn't add this on the end when we go and have a look at the running config, because by default it is the management interface. We will then set peer gateway for future use, auto recovery, so that in the event that one of the other switches dies, it will count down, make sure that everything's down with that one. It will then recover this switch so that traffic will then start passing again. It's a bit controversial. You might or might not want to do it because you might end up with a split brain scenario where you have both switches that are online and both trying to pass traffic, and it can cause problems. But the likelihood of it happening here between these two is very rare. And then finally, we will do an ARP synchronization. If we do any layer 3 VLANs on here, we'd like to keep those synchronized. So that should be it for our VPC domain configuration. We should be able to do a show VPC keep alive. Okay, we can see the keep alive is currently suspended because the other side's not up. So what we'll do is we'll jump over to the other side and we'll get that bit configured, and we'll then do the peer link between the two. So again, we log into the secondary switch. We're going to need some features. We're going to need LACP, and we're going to need vPC. We'll jump onto the management interface. Description, we're using it for the keep alive. Its IP address is going to be 10.1.1.2. Make sure that it's not shut down. We're then going to set our VPC domain of 100. Domain of 100. Perfect. We'll set peer switch. That makes the switch appear as one switch to the device below. We will need to make sure that we set the exact same spanning tree priority on both switches for all of the VLANs that we have running. So we set our peer switch. We're then going to set our role priority. The other one was set as 50. We'll set this one as 100 as the secondary. We'll then again set our system priority, and it has to 8192. It has to match the other side. We'll then do our peer keep alive. The destination is 10.1.1.1, which is core switch 1. The source is 10.1.1.2, and again the VRF is the management. We'll then just do our peer gateway, our auto recovery, and our IP ARP synchronization, and that should be that bit done. Now if I do a show VPC, we should be able to, there we go, peer keep alive. There we go. So we can see that the keep alive connection between the two management interfaces is now up and alive. So they are now keeping track of each other. Now we're going to configure the VPC peer link, which is where all of the data flows across. So we'll jump back over onto core switch 1. We'll configure this now, and we're going to first configure a port channel. So we're going to do interface port channel. We're going to put this up high so that we don't confuse it with the ones that we configure down here. So interface port channel 1000, the description is going to be peer link, so we know what it is. Okay, it's operating in switch port mode. Switch port mode is trunk, because it's obviously carrying VLANs. And our spanning tree port type is network. We have to do this on both sides. And then finally, we set it as the VPC peer link. Just no shut, just for good measure, just to make sure. So now if I show run int PO1000, so there's our peer link configuration, the port channel. We copy that, we'll stick that over on core switch 2 because it's an identical configuration. And now we'll configure the actual physical interfaces for those. So now if we jump to, if we look, we've got 6 and 7, I think we are. So int e1/6 to 7. Description will be link. We'll call this let's call it peer link as well on both of those. And we will then put down switch port mode will be trunk, and we'll come back and the channel group 1000 mode active. Shut. That should be enough for that. Show run int e1/6. Yep, that looks good. So if we copy that, come over to here, int e1/6 to 7. Pop the same on here. There we go. So that should now, if we do a show VPC, we should see the VPC link come up. And there we go. After a bit of synchronization, we can see that we now have on switch 1, core switch 1, we have our VPC adjacencies formed. So it can see the other form. We can see that all of our configuration is successful. We can see that this one is operating with the role of primary. All of our configuration options that we turned on are selected, and we can see that the VPC peer link is up. If we come over to switch 2, we can see the exact same scenario. It is up and running. Show VPC. There we go. We can see our full details. Show VPC peer keepalive, and we can see our keepalive is running as well. So that's it. We've got our configuration operational. Now what we're going to do is we're now going to configure the 4 top of rack switches, and we're going to create the port channels for each of these switches so that they can have a 20 gig trunk back to the core, and then we will allow VLAN 20 to pass from each of the top of rack switches so that all 3 of these devices can ping each other and reach the gateway that's operating in top of rack switch 4. So we jump back onto this side first and we'll create the VPCs, because this side of the configuration is pretty standard. It's just like configuring a standard port channel that you would configure on any other Cisco switch. It's a bit different on the VPC side, so that's why we'll start there. So if we start on core switch 1, and we can see if we do a show int status, okay, so we can see we've got our 1, 2, 3, 4. We can see we've got our 4 ports. They're unconfigured, but they're just sitting there. So what we'll do is we will start by creating each one of these VPCs, and we have 4 of them. So we start by creating a port channel. So in PO 10 and VPC 10. So that gives it its VPC. So we create a port channel, we're giving it a virtual port channel number, best to match with the thing so you can keep them consistent. So description, this will be VPC 10. Just so we know what it is. Switch port mode will be a trunk. And on here we are going to guard root because we should be the root up there, not down there. And that should be it for that one. So what we'll do is show run int PO10. So this configuration is going to be the same. So stave typing. So now we'll do int PO20 VPC 20. Paste that in description VPC 20. Cool. Int PO30 VPC will be 30. We use switch port mode trunk and we guard the root, and we set a description VPC 30, and then finally in PO40 switch port mode trunk, spanning tree root guard, description VPC 40. Show run. So we should see we've got our 1, 2, 3, 4 port channels configured on core switch 1. They're all identical. So what we would do is we also need these over on core switch 2. So we will take these and we'll pop them over here. So now we've got our VPC port channels configured on core switch 1 and on core switch 2. Now we'll add each one of the physical links to be a member of each one of those VPCs. So back over here again, so we know in int e1/1, switch port mode is trunk, and it is a channel group 10 mode active, no shut. Just to be on the safe side. Now we do int e1/2. It's going to be a trunk. It's going to be a member of port channel 20. No shut, just to be sure. And jump onto port 3, same again. It's going to be a trunk. And it's going to be part of group 30. No shut it, just to make sure. Never know with EVE-NG if some of these interfaces start to mess up. So finally, int e1/4, switch port mode trunk, channel group will be 40, no shut. And what we can do is we can copy this straight onto switch 2, because thankfully 1, 2, 3 and 4 are all going into the same VPCs, so we can copy pasta those over onto the other switch, and that saves us typing. So we have interface 1, 2, 3, and 4. We will bring those over here. And if we have a quick check on switch 1, we can see we have, when we issue the show VPC command, we can see we've got our VPCs here. They're showing down at the moment because the other side hasn't been configured yet. But we can see the consistency is correct. If we check over on switch 2, again, 1, 2, 3. Oh, we're missing 4. Where's 4? Ah, I forgot to set port channel 40 as a VPC. Int PO40, VPC 40. Do the same over here. This is why you always check. Show VPC again. 1, 2, 3, 4 port channels, 4 VPC IDs on switch. Core switch 1. 1, 2, 3, 4. 4 port channels, 4 VPC IDs on core switch 2. Perfect. So let's save our config. Let's do the top of rack switches and get these tunnels, these port channels up. So if we start over here, we can see again, we've got a blank switch. So we're going to start by creating a port channel. And so on this side, we only need the feature LACP because we're going to be using LACP port channel. We're going to create a port channel. And this is just going to be a switch port mode trunk. So all we need on this side is the LACP feature. We're going to create a port channel 1 and we are going to give it a name, switch port mode trunk. No shut to be short, and then we're going to put E1 and E2 as members of that port channel, and that will then create a trunk and a port channel interface on this side, which will then bring the VPC up to both of the core nexuses. So int E1/1 2 switch port mode trunk. It's going to be a channel group 1 mode active. I'm going to copy and run start that. So show int status. We can see we have 1 and 2 as a trunk, and they are members of the port channel, which is showing as up. And if we go back to the core switch, and we now show our VPC, we can see our first one is up, and there's one active VLAN, VLAN 1. Perfect. So now let's do the rest of our switches. just like that. Two ports, 1 and 2, configured as a trunk. Port channel created, connected, full. Jump back over to the core switches. We can see port channel 20, VPC 20 is now up. We check over on core switch 2, we've got the same. So we've now got our port channel terminating to 2 different switches. We've got the extra bandwidth and we've got the link redundancy. So switch 3. Feature LACP. Create a port channel. Switch port mode will be trunk. Switch port mode again on here will be a trunk. Channel group 1 mode active. Showing status. Oh, made a mistake. Was on the wrong switch. We're going to have to revert. Ooh. So what did I mess up? Right, first of all, we shouldn't put that on there. So config T, no int PO1, and show run int E1/1. That should be a trunk, but it should be show run int E1/3. Okay, that's correct. So int E1/1 channel group 10, and that was mode active. That fixes that. Int E1/2. That should be part of VPC 20. That fixes that. Let's double check. 10, 20, 30, 40. Port 1, yes. Port 2, yes. Port 3, 4, yes. Okay. Open up. Double check if you make a mistake. Yes, yes, yes. Right, so we want switch 3. Sorry. We'll leave that in because mistakes do happen. It's just how you fix them. Feature LACP. PO1. And again, on this side, it doesn't matter what I number the port channel because that's not what matters. Switch port mode trunk. Int E1/1, 2, switch port mode is trunk, and again, channel group 1 mode active. Show int status. We can see again 1 and 2 are connected. They are trunks and they are connected to port channel 1. Let's just verify on this side after our little mistake. We can now see port channel and ID 30 is up. On switch 2, core switch 2, we're getting the same. Perfect. Finally, core switch, top of rack switch 4. Feature LACP for port channeling. Int PO1. Switch port mode is trunk. And then int E1/1 2. That's the range. So we're doing the same configuration. So switch port mode, trunk, and then channel group 1 mode active. Show int status. 2 ports from this switch are configured in a trunk, and they are connected to port channel 1, which is connected. So now if we go back to our 2 core switches, we can see all of our port channels are up. All of them are up. Good. So now let's add VLAN 20 on the core switch. So let's add VLAN 20 on core switch 1. And then we are going to spanning tree VLAN 1 and 20, because those are the only 2 VLANs we've currently got running. And we're going to set the priority on both of the core switches. So we're going to be 4096. And we'll do the same over here. VLAN 20. And then we'll set 120 priority. VLAN 1 and 20, the priority will be 4096. Okay, so we can now see we have 2 VLANs on both of our switches, and they are currently allowed across all of our trunks and across the peer link, which is correct. Anything that is traveling on a VPC needs to be allowed across the peer link. So that's good for our core switches. We can now save those. Our basic VPC configuration is complete. We will now just add more VLANs as and when we need them and tag them across the trunk links as normal, and then add our devices on the top of rack switches. So now on the top of rack switches, we will add VLAN 20. And what we will do here is we will configure VLAN 20 so that it can now go across the trunk. And now we'll put this switch port as an access port for the device. So int e1/3 switch port, it's going to be a host. Switch port access VLAN 20, no shut. So that is top of rack switch 1 done. VLAN 20 int e1/3. I love how they're all the same. So switch port mode is host. Switch port access VLAN 20. Add VLAN 20 onto the switch. Int e1/3. Should have done a video on VTP. I did. If you missed that, it's on the channel. You can check that out, and it shows you how to configure Cisco VPT or VTP. Switch port host. Switch port access will be VLAN 20. And now that we have all of our switches configured, our top of rack switches have all of their access ports configured. They all have VLAN 20. The core switches know about VLAN 20. All of our port channels from our access switches back to our VPC pairs are operational. We should now be able to pass traffic from all of our devices. So let's open each one of our test servers. And from 6, which is this one here, I should be able to ping 192.168.20. What is the address for the next one? 20.20 and 20.30. I've given this one the wrong IP address. So 20.20 20. And there we go. So now traffic is now running from this device over to this one via the port channels or the VPCs up to the core and then back down to the next top of rack switch and into the server. If we check, we should also be able to hit 30, which is now coming up again and then coming back down the VPC 30 into top of rack switch 3 and hitting server 8. On top of rack switch 4, we have our gateway device configured, which I think had a gateway address of 254. And after starting the gateway, we can now see the gateway is now reachable. And as it is the default gateway, I should now technically be able to ping out to the internet, which I can from this device. So now this device can see all of its other devices in the rack within the VLAN of 20, and it can also reach the internet. Next, we'll test some failover scenarios. So now what we'll do is we'll send some traffic from server 6 and we'll send it out to the internet for a count of however many that is, so it will just keep pinging. And what we will do is we will test if we kill core switch 1. It will take probably about 2 minutes, but we will fail over onto the secondary node and it will take full control of the traffic flow. So if we bring that there and if we stop it, that hard stops it, we should see a breakdown in traffic flow. Once the peer keepalive notices that the other peer is gone, we'll see that the traffic stops. Now we can see it's seen it fail. And we can now see that spanning tree has started to block. So if we look, there we go, we can see traffic is now being blocked whilst the timers start. So we'll see that this is now going through its recovery process. And so it's going to basically stop all the ports to make sure that nothing can cause a split brain or any kind of loop. And once it's happy that all the ports are fine and there's no issue, you can see here it's unblocked it and cleared it. And there we go. We can see traffic has now resumed. So we dropped a bit of traffic whilst we lost an entire switch. So we lost an entire core switch, but the servers in this cabinet were still able to maintain their connectivity to the internet. Now let's bring core switch 1 back online. And whilst that's booting up, if we take a look at the VPC configuration on here now, we can see the keepalive is suspended, obviously because the peer link is down between the two devices and the keepalive is down between the two devices. We can see that this node 2 has taken over the operational primary role. Its default role is the secondary, but it's taken over as the primary. We can see that our port channels to our access layer are up, but they're being bypassed because checks are being bypassed because we have our other switch offline at the moment. What will happen now is switch 2, core switch 1 will now boot back up, and it will say here that it is the VPC role of primary, but it will assume the operational role of secondary, and it will sit there and wait and it will fail over and become primary if core switch 2 was to ever die. I think that pretty much covers what we need to cover here in this video. In the next video, we're going to be covering a scenario where we build 2 VPCs and we're building them in 2 separate data centers, and we're going to connect the two VPC pairs between two data centers using data center interconnects. And that allows us to span VLANs from one cabinet in a data center over to a secondary data center. Obviously, you can only support two data centers with that setup. So here we can see, yes, we don't have the redundancy as well at the access layer, but again, we could build, if we wanted a highly available cabinet, we could very easily build another Cisco VPC pair down here at the cabinet level and connect it up to the cores, and then we could have our devices connected redundantly into that layer there, two switches, with two chassis switches and LACP from our server into the two switches. The reason it's set up like this in the lab environment is to demonstrate the failover. If I had a server plugged into core switch 1, once it goes offline, it's not going to be able to ping anything. So at least with this lab scenario here, I can demonstrate the packet can still reach the other devices because an entire switch goes down, because it will take the secondary path. So I hope you found that useful. Please like and subscribe. It helps grow the channel. And like I said, watch out for the next video where we do a data center interconnect, and then maybe we'll also add a second layer as a VPC cluster down in the rack cabinet as well. But I hope you found that useful. There's more in the documentation on the Cisco website, but the main configuration I've shown you here should give you all that you need to be able to get this operational and put it into use. So I hope you enjoyed the video, and I'll see you on the next one.